So this is getting started with WinUI and Windows App SDK, and also with .NET, because this is all using .NET if you're doing C# projects. So a little bit about me. I've been in the industry for almost 30 years now. I have a blog, The Morning Dew. It's at alvinashcraft.com. A lot of you may be familiar with that. I post links to .NET resources for developers every day. I've also written 3 books for Pact Publishing. 2 of them are 2 editions of Learn WinUI 3, and then I have another one that's on parallel programming and concurrency with .NET. And like I said, I've been at Microsoft since 2022, just over 3 years now. Content developer working on the Windows developer docs on Microsoft Learn. And I'm an organizer too of a developer conference. The Tech Bash conference happens every fall in the Poconos, in the Pocono Mountains in Pennsylvania. So that's Tech Bash. We're in November this year. If you're in the area, you should join us. We're going to have a lot of great speakers. We'll be announcing some keynotes very soon. And the agenda. So I've got a couple of things struck through here. I normally do about a 60 to 75-minute version of this talk. So I've cut out a few things for this version of the talk, but all of the slides for everything and all of the code samples are all up in my GitHub repo. It's just alvinashcraft/speaking. So you can go up to GitHub and get the resources for all of these demos. So let's start with a quick overview of WinUI, and then we'll get into some code quickly here. So WinUI is part of the Windows App SDK. The first release was in March of 2021. That was 1.0. WinUI 3, they call it WinUI 3, but it's not really a version number. It's kind of the successor to WinUI 2, which was an add-on to UWP to add some additional controls and libraries. And WinUI 3 is completely its own thing with the Windows App SDK. It's very similar to UWP. If you've done UWP apps on Windows 10, what they did was they took those controls and libraries and extracted them from the Windows SDK so that they could version these components independent of Windows. They used to be stuck with waiting for a new Windows release before you could get new UWP features, and now it's all separated out. The main difference between UWP and WinUI as far as looking at the code is the namespaces are changed. So everything starts with Microsoft dot instead of Windows dot in the namespaces. It's built on the latest .NET runtime. Right now you can build WinUI apps with .NET 9 or .NET 8. Both are still supported. You create apps with XAML and either C# or C++. And if you use C#, you're also using .NET, and you have access to the full .NET libraries, runtime, everything. And the latest release of Windows App SDK is 1.7. That just came out about 3 weeks ago. And it's open source on GitHub, not full open source. You can't contribute code yourself, but they do publish read-only versions of the code so that it helps with debugging. You can get access to all the source. And let's see, we're going to dive into the first demo here. So there's going to be 2 parts to this demo. So I'm going to create a new WinUI project from scratch and then show you how you can add a couple of things to make it look a little bit nicer. And then I will open up another project that's got an MVVM implementation, model view view model. And it's also got some controls and some styles added. So you can see the difference between the basic out of the box and what you can do pretty easily, just adding a few styles and controls to your app. So let's start with a new project dialog. We'll create a new project in Visual Studio. And we're going to pick a blank app packaged WinUI 3, and this is C#. And we'll just leave the name app 3 for now and hit create. So this loads up a couple of files here in your project. Let's see. So if we zoom in a little bit there, you can see this better. So we've got an app manifest. We've got an app.xaml, which is the part of the program that launches your app. So it goes into the app class first and then launches the main window from there. And the main window is exactly at the main window. Let's take a look in the app.xaml just for a second to see how that's created. So in the onLaunch method, it just creates a new instance of the main window and activates it. And then in the main window, the new project just gives you a blank window with a single stack panel. Stack panel just does exactly that. Anything you put inside there, it'll just stack the controls either horizontally or vertically, depending how you set that up. So this one is horizontal, so it would stack things left to right. And then in the code behind, each XAML file has a C# code behind file where you can put code. So here there's just a button click event handler. So when you click the button that's in this UI file, it'll call that event handler. Let's just run this. I'm going to change this to ARM64. I have an ARM laptop here. Run it with no changes and see how it looks. It's building and deploying. And it's pretty basic. It's a big empty window except for the one click me button there. And you can see it's got a title bar with no icon yet. If I click that, it just changes it to clicked. And now I want to show you a couple of quick things you can do to make your window look a little bit nicer. I have this other app here. And this is exactly the same code, except I've added a few extra things. So the first thing I've added is this mica backdrop. And what that does is it gives it a little bit more of that Windows 11 look and feel. I'm going to take that and just paste it in our new project and run this again so you can see the difference that one little attribute makes there. And you can see it kind of has that pinkish hue now, so it's almost like it's picking up the color of your wallpaper in the background. So I've got a purplish hazy background and it's pulling that into the window here. Let's stop this and go grab the other piece that I have here. So the rest of this, so instead of just the stack panel, I have a grid wrapping it, and I have two rows in the grid. The first one has a custom title bar, and this is a new thing in Windows App SDK 1.7. It's a title bar that looks a little bit more like what you see in other Windows apps. You can add more things into the title bar, like you'll see in this WinUI 3 gallery app. You know, it looks like a little bit bigger. It's got a nice icon here. It's got a back button in here, and you'll see some apps like the Windows Store. They even have like a search box up in your title bar. You can do all that with this new title bar control. Let's go back to this app, copy this, and put it in here. So we've added this new title bar. I'll call this sample app. We'll put that in the title bar. I'm hiding the back button, and I'm not making it a tab stop because we don't have any controls up there that we want the user to be able to tab into. And I have to get one other piece to make that work. In the code behind, there's a set title bar method that we're going to copy and call that from the constructor. So let's paste that in here. And call it. And so here you'll see I'm setting the icon. I'm telling it to make it the taller height and setting the display name here as well. Let's run this again. And if we did everything right, we should have this nice tall title bar, but we don't have the icon yet because I forgot that step. Let's get our icon in here, add it to the assets folder. We're going to add an existing item. I'm going to browse out to this other place where I have an icon. And it's a WinUI icon. Now we've got that. Ooh, I got to do one more thing. We'll stop that. We have to go and set the properties on this so that we set it as content. Instead of build action none, we're going to say build action content so that we can reference it in the code. Now we should have an icon when this launches. There it is. We've got the larger title bar, looks a little bit nicer, and we got the icon set there. And it still works just like expected. When you hit the button, it says clicked. So that's a basic app. I'm going to pull up something with a little bit more to it now. These are all the samples that are out of my GitHub repo. We're going to start with this controls and MVVM solution. And in here, you can see I've got a lot more going on. So we still have a main window and an app.xaml, but we also have some other views and view models. So in the main window now, you'll see there's nothing in there. It's just a window with the mica backdrop. So in here, instead of having the everything in the main window, we're loading each of these other views as a page inside the window. So all of my markup for what we're going to be launching is here in the main page. And this main page will get loaded, I believe, in the app.xaml. Let's take a look here. So on launched, we're creating the main window and we're adding a frame to the window. And then we're telling it to navigate to the main page within that frame. So before we dive into any more code, let's just launch this and show you what we're dealing with. So this is a media collection app, so you can enter in your CDs, books, Blu-rays, DVDs. You can enter all that media here and create your collection. It's got a drop-down box to filter by type, so if you only want to see books, it'll show that, or you can go back and show all. I can select items, I can edit it, or I can delete it. If I don't have anything selected, I can add items. Let's hit edit. And one of the other cool controls here is this teaching tip. So what you can do with a teaching tip, by default, it'll show every time, but you can add a user preference to save whether the user has already seen this tip. So once they've seen it one time, you don't show it to them again. It's just telling them how this drop-down button works. So they can save and create new or save and return once they've made a change here. So let's say this is no longer in my collection. I've loaned it to somebody. So now I can hit this. I can either save and create a new item, or I can save and return to the list. Let's create new. And we'll add an alien movie to our list. A video. Let's say it's a Blu-ray, and it's in our collection. Now I can save and return, and we've got all 4 items here. So let's take a look at some of the code for this and see how this works. So in the main page, we've got separate grid for the stuff at the top. So in the top, we've got the header. We've got a stack panel that stacks horizontally for the label for the drop-down box that filters by type, and then the combo box itself. And this is using data binding. So we can bind to things in our view model to show them in the UI. So I'm binding the list of items to this list of mediums in the view model. And then I set the selected item based on that property. And then for the bottom part, I'm using a list view control. And inside the list view, I have both a template for the header and a template for each item in the list. And you can see for the styling, we're using theme resources. This will make sure it'll pick up the light and dark mode or any other color changes that the user makes in their system. If you wanted to instead brand it to your own company colors or something, you could hard code or create your own theme based on your company logos and things. And at the bottom, we have another stack panel that's got the buttons. And these are both regular standard buttons, and these are binding a command to the view model. So the command is what's going to be executed when the user clicks on there. So it'll go into this add edit functionality or the delete. Let's take a look at the view model that corresponds to this. So if you've done any XAML development and used model view model, you may have done your own implementation of an observable class or a bindable class. I'm using the MVVM toolkit, which is part of the .NET community toolkit. It's open source, available up on GitHub. You can get references into your project through NuGet. So if I look at our NuGet packages here, let's see, I've got the MVVM toolkit, and these are all other standard WinUI packages that you'll have here. So by using the MVVM toolkit, it reduces a lot of code that you would normally have in your view model. All I need to do is make my view model a partial class and inherit from observable object. And by doing that, it's going to create, it uses source generators to create another partial class with the implementation of all the public members. So for a property, I only need to create the private member, the selected medium in this case, and when it builds and runs, it's going to create a public property called selected medium with capital S. So anything that's decorated with observable property will create a corresponding public property for you for data binding. And I can also, if I go down to my commands here, so here's the add edit. You see this is private and it's just called add edit, but I've got this relay command decorating it. So that creates the add edit command that's public. That'll be bound in the main page here. So this add edit command is created by the source generator. And then within that command, it calls this private method. So when I hit the button, all of this executes. And if I hit delete, this is the code that gets executed. And I've got some code to validate whether the delete button should be enabled. Anytime that this can delete item is called, it's going to check if there are any selected items. So I can only hit delete if there's an item selected in my list. Let's take a quick look at the item details view and view model. We'll look at the view first. We'll go down to that teaching tip. So here's the teaching tip and the split button. So the split button has the drop down with the two buttons inside of it. And to show those, it uses a flyout with the stack panel and the two buttons inside there. And the teaching tip here, we just data bind that to the save button, and that will attach it to that. And in the back here, we have some little bit of navigation logic so that when we open up here, we're setting the teaching tip. This is where it's, if you had some local settings, you can check whether the user has already viewed that teaching tip, and you can set whether it's visible or not. I just have it hard-coded to false so that we'll see it every time that I do this demo. And the other bit that's important in the code behind here is whenever we navigate to this page, we're just populating the initial data if there's already an item selected. So if there's an item ID, then we're going to be editing. If there's no item ID, then we know we're adding a new item, and we should have an empty form. So that's the basics of some controls. Let's jump back to the slides and get to another demo here. So the next one will be the using the Windows Community Toolkit. So there are different community toolkits available from Microsoft that are open source. There's the .NET Community Toolkit I mentioned with the MVVM stuff in it. The Windows Community Toolkit There's some Windows-specific stuff. You can use the things in there for UWP, WinUI 3, and also Uno platform. So there are animations, triggers, behaviors, controls, and other helper classes in the toolkit. It's open source on GitHub here. There's documentation on Microsoft Learn about the controls and things in the toolkit. And there's a gallery app on the Microsoft Store. We'll take a look at that quick. I've got that open here. So within the gallery, you can explore everything in the toolkit and see things working in the UI to see how they look. If I go to items view, so it shows you what the items view looks like. It's running live here in the app. So if I expand the source code, it shows me the code that was used to create that. So you can copy and paste from here to get started quickly. It shows you the XAML code for that and also the C# for any stuff in the code behind. And with some of the samples in the Toolkit app, you can change some properties to see how it will look in different layouts. So it's got 3 different layouts that you can pick from here. You can change the amount of space between them and space these out a little farther. And we can change the selection mode for this item. So right now it's multiple. I can select multiple items. You can change that to single. So the checkboxes are gone. You just select one at a time. So let's take a look at a sample app that's got this in it. So I've got a community toolkit solution here. And you'll notice for some of these solutions, I have both a solution and a solution X, SLNX. Some people are calling these slinks files. It's a new solution format that's currently in preview. It works with the Visual Studio 2022 preview version. And these are a lot nicer to look at if you ever opened a solution file and you've seen all the GUIDs in there. The solution X files have no GUIDs and they're much simpler to look at. We won't demo that here, but you should go check it out. So here I have a hardware supplies app. Let's run it first to see what this looks like. Call it hardware supplies, but it's got a list of hardware items and then another color picker control here. So you'll see I've got a data grid with some hardware items in it. In this control, I can resize the columns nicely, like basic data grid functionality. And you'll see I've also got a little shadow around here. And I've got some text here with a shadow on it. And my color picker control, I'm using data binding to bind to this shadow color. So if I change the color that I've picked here, it changes my shadows in real time. Anything I change there changes. You can change the type of selection. And that's one of the controls in the community toolkit. Let's take a look at the code for this. So in our main window, there we go. So I've got the mica backdrop on here as well. And for the drop shadow, using an attached drop shadow from the toolkit, I named it Common Shadow. And I'm binding that to the color picker and setting the path to color. So that's telling it to pick up the color property from the color picker and use that for the shadow color. And then down here, this header content control, that's that was the header at the top. And I've got a drop shadow panel, which is also binding to the color picker to pick up that shadow color. And this is my data grid. All I'm doing here is binding the item source to a list of hardware items that are hard-coded in the back code behind here. Just got some code to add a bunch of items to that list. And then finally, we've got a grid at the bottom that contains the text block for the final shadow. It says, I love hardware and all related supplies. And I set the effects.shadow property to the common shadow that's up in the resource at the top. And finally, the color picker. It's got a lot of different properties you can set. So I'm setting the spectrum shape to a ring. You can enable and disable some different things about whether you want to have the different sliders and other picking elements available. And then I'm setting the default color when it launches to be my system accent color. So whatever the user's system accent color is in Windows, that'll be the color of the shadows when you first launch. And in the code behind, like I said, there's just the hardware items, and then we've got the code to set the title bar up. All right, let's move on to another demo here. We should have time to get to a couple more. Notifications. So the notifications API in the Windows App SDK lets you use toast notifications in Windows, and there's a couple different types that we can create here. Let's pop open that demo project. And most of these demos are adapted from samples in my book. I've got a chapter on notifications that I pulled this demo from. So we've got the media collection app again, but it's been enhanced a little bit. Let's launch this. We've got a couple of extra buttons at the bottom when this opens up. So we don't have the special title bar here. It's got the standard title bar that you get out of the box, but we do have some new buttons down here for notifications. So we can send a notification, or we can send a notification that will also have a text box for a reply. So let's try the initial regular notification. You can see it pops up a toast. And if your app is behind something, I can click Open App and it brings it to the front. And I get a pop-up saying we received this notification to open the app. We'll hit OK there. I'm also using a status bar to show the current status. Last thing that happened was the notification was received. The next notification we'll send will have that text box. Here's our toast. And now I can enter a reply. So I've received that. If your app was in the back, it would have brought it to the front again, but our app was at the front. Here's the reply. It says input received was hello C# TV. And we click OK there. So let's take a quick look at how that code is implemented, but there's a link in my list of links in GitHub that points you to the Microsoft Learn article that could walk you through all of this step by step. So we have a few extra classes here. Let's go to the helpers. We've got toast with text and toast with avatar. These are two different, they're like templates for creating your toast. So here when I send the toast, I'm adding arguments for the different scenarios I have. I'm telling it to use this icon, cropping the image to a circle when it appears on the toast. Here's the text that'll appear on the toast. And this is the text box. We're adding a text box to it. And this is the pre-populated text that will show in the text box for the user. And there's a button. So the button on the toast says reply, and the action is reply. And that's what we got back in the message that appeared on the screen. If we look at the other one, the one without the text box, it looks pretty similar, but we just go from text to button. We don't have the text box in this one. And then we've got a notification manager. This is where we register to receive notifications. So in the initialize here, we're setting up an event handler to find out when notifications are invoked and calling this register on the handler. When messages are received, we're going to process them here. We're going to send the notification out to Windows. And then this is this notification shared. These are all the updates that we received in that status bar. So the status bar in the app gets updated based on which one of these we've called from the manager class. And finally, notification received. If there's any issues, we just pop up a message saying there was some unrecognized message that was received. And like I said, this is all out on Learn. This is my speaking repo, but this is the page within this conference's stuff. So I've got all the links for all this. And if you go to the notifications here, Windows App SDK app notifications. So this overview gives you a little info, but then there's a quick start that walks you through all of this on how to set up the notifications for your own apps. All right, next, we don't probably have time to go through all the Interop demos, but there are a couple different ways that you can do Interop. So there's XAML islands. So this was added in Windows App SDK 1.4. And right now they're still working on enhancing this, but you can only use the XAML islands to show Windows App SDK WinUI stuff within a C++ app. So you can't use this in other WinForms or WPF apps yet. But there's a sample up on GitHub from the team that shows you how to implement this in a C++ app. And I do also have the code in my repo. And we don't have time to walk through the code, but I can run this quickly and show you how it works. Let's run this. So this is a C++ project, and it's within here, it's got a couple of Win32 buttons. These are C++ buttons. And then within there, it's also got some WinUI content. So everything from this toolbar down is all WinUI content. So we've got a web view control that's WinUI. It's got some WinUI buttons, text box. So all of this is embedded within the C++ app. And the other way that you can do Interop, let's go back to PowerPoint. So you can use the web view control to embed web content within your WinUI apps. And I have a sample that embeds a Blazor app inside there. So let's run that quickly just to show you what that looks like. So I've got two projects in here. I've got a Blazor project that uses WebAssembly, and I have that running out on the web, so we don't have to kick that off here. This is my WinUI project, and this will just load up our Blazor content from the web. Let's run this. And when this opens, it's just going to be a WinUI shell with your basic Blazor Hello World app. This is what you get when you create a new Blazor project. Most of you are probably familiar with this. This is all running in the web. Take a look at this code quickly. Control Z. So the only thing in here is the web view control, and I'm just pointing it out to where my Blazor app is running online. Nothing else here, nothing in the code behind. It's just loading up the Blazor app. Let's jump back to the slides and see if we can get through a couple more quick things. Deployment options. So there are different ways that you can package your app, your WinUI apps. You can make them framework dependent or self-contained. So framework dependent apps depend on the Windows App SDK runtime being on the client machine. And self-contained apps, when you deploy your app, you're deploying the Windows App SDK runtime with your app. So you have more control over the size of, or you have more control over the versioning of your package that your app has. But the size is going to be obviously much bigger when you're deploying the whole runtime along with your app. You can deploy out to the Microsoft Store. You can deploy through WinGet. So up on the WinGet repository, you can put your app up there. There's ways that you can sideload. I've got a link here for instructions of how .NET MAUI Windows apps can be sideloaded, and that same process works for any WinUI app. And there are also third-party installers. So Install Shield, Advanced Installer, all those things can work with your WinUI apps. And we won't be able to get into Uno Platform, but I can explain quickly. So Uno Platform is multi-platform solution, kind of like .NET MAUI, but they can also run on Linux and on the web with WebAssembly. So you can create a single code base that runs on iOS, Android, Windows, Linux, just about any platform, all from the single code base. And the XAML used in Uno Platform is WinUI XAML. In my book, in the one chapter where I show an Uno Platform demo, I just take my WinUI code and I copy and paste it into an Uno solution, and it's the exact same code that I can now run on any platform. And the latest releases of Uno also have hot design, which lets you drag and drop design your apps at runtime. So while you're running your app, you can open up this designer and make changes, and it'll save those changes back to your project, and you can see them at runtime. And we're not doing the demo of Uno. Final thing here, the WinUI roadmap. So Windows App SDK 1.7 was just released, and 1.8 is up next. They just released the first experimental release of 1.8. The new things in 1.7 were a lot of things that people had in UWP that were missing. Background Task Manager is now available in WinUI. Camera Capture UI, so you can use the camera in your PC to capture images. The new title bar we saw, and the OAuth Manager, so you can do OAuth authentication in your apps. And they're working on a XAML designer. Right now, there's no UI designer for WinUI apps. You have to hand code all your XAML, but they have started work on a XAML designer in 1.7, and they'll continue that work in 1.8. And this QR code goes out to the roadmap for Windows App SDK. And let's see, if we have a minute left, I have one other demo that's not part of the slides, but it's pretty cool. In the current experimental releases of Windows App SDK, there's some AI stuff that you can do. So this Windows Copilot runtime, this project can only run if you have a Copilot Plus PC that's got the local Phi Silica AI model on it. So what this has, let's just run it and you'll see what we've got. So this is going to use the local model on my machine. And if I pop up Task Manager, we can watch the NPU do its work. So here's my NPU, my neural processing unit on my machine. And you'll be able to see the GPU and CPU activity as well as we run this demo. Let's see if we can resize this a little bit to get everything to fit. All right. So here I have a prompt, provide the molecular formula for glucose and explain its properties. And we're asking it to please give us some markdown formatting to make it easy to read. So in these APIs, there are different kinds of queries that you can run against the local model. You can do a general query, which is just your usual questions that you'd ask the AI. You can ask it to rewrite your text, summarize text. If you have a multi-page item that you'd paste into here, you can ask it to summarize it. And you can also do text to table, which will create a table of items from whatever you paste in there. But we'll just do a general query quickly here. And it's thinking. And we should see the MPU start to take off a little bit. It's starting to get busy. There it goes. Meanwhile, my CPU is pretty flat, not much going on there. GPU is also not working. Everything's happening on the MPU. And in the code here, I'm telling it to feed the data back to me as it's being generated, so we don't have to wait a long time for the whole thing to be created before I show you the output. We're getting this streamed back to the app asynchronously. So we'll wait for this to finish up, but there should just be a couple more lines, and then I'll show you the code and we'll wrap up. This checkbox to show progress, this is what controls whether it feeds it back as it's going or if it just does one call and wait for everything to come back. And while we wait, oh, there we go, it's finished. The other thing I have here is a checkbox to say use a strict content filter. So that will filter content, has violence filters, has different filters that I'll show you in the code here. Super quick. Let's close that. So here's where I'm checking if we want to show progress. So if we want to show progress, it uses this generate response with progress. And then we've got a callback to show the results as they're coming in. If I want to see everything at once, I just make a single call to generate response async, and I get everything in the result and populate that at the end. The other thing I've got is like I mentioned, content filters. And I've got a thing down here, apply content filters. So if the checkbox is checked, it's setting all these filter options for violence, hate content, sexual content, self-harm content. So all of that can be filtered out with these filters. And this is all running locally, nothing pinging the web for this AI call. So like I said, that's in the experimental release. Hopefully it'll make it out to a stable release very soon. And that's all I've got.